Hello friends, welcome back to Simply Study. In this video, I will explain you the solution of Basic Electronics paper of GTU November 2018. The topics which are asked in the paper are very important, and instead of just reading the solution, you can find a video solution of the GTU papers over here. You can also download the GTU question papers and the solution in a PDF from the link mentioned below. So let's start with question 3. Question 3a states that derive the relation between current gain alpha and beta. This question carries 3 marks. Current amplification factor alpha is the ratio of output current to the input current, where output current is collector current and input current is the emitter current in a common base connection. Alpha equals to change in IC upon change in IE at constant VCB. The value of alpha is less than unity. By decreasing the IB, that is the base current, value of alpha can be increased. Base current amplification factor beta is the ratio of change in collector current to the change in base current. Generally, the value of beta is greater than 20. A simple relation exists between beta and alpha, which can be derived as follows. Beta is equal to change in collector current to the change in base current. Alpha equals to change in collector current to the change in emitter current. We can mark these equations as 1 and 2 respectively. We know that IE is equal to IB plus IC, implies change in IE is equal to change in IB plus change in IC, implies change in IB is equal to change in IE minus change in IC. Substituting the value of delta IB in equation 1, we get beta equals to change in IC upon change in IE minus change in IC. Dividing the numerator and denominator by change in IE, we get beta equals to alpha upon 1 minus alpha. It is clear that as alpha approaches unity, beta approaches infinity. In other words, the current gain in common emitter connection is very high. This is why this circuit arrangement is used in about 90 to 95% of all transistor applications. Let's move to next question. Question 3b states that what is DC load line? Explain with necessary diagram. This question carries 4 marks. Graphically, a load line is a line drawn on the characteristic curve, a graph of the current versus the voltage in a nonlinear device like a diode or a transistor. The points where the characteristic curve and the load line intersect are the possible operating points or quiescent points or Q points of the circuit. Consider a common emitter NPN transistor circuit as shown, where no signal is applied. The output characteristic of this circuit are also shown. The value of VCE equals VCC minus ICRC, which can be marked as equation 1. To obtain the load line, the two endpoints of the straight line are to be determined. Let those 2 points be A and B. To obtain B, when the collector current IC equals 0, then collector emitter voltage is maximum and will be equal to the VCC. This gives the maximum value of IC. This is shown as VCE equals VCC minus ICRC, which is equal to VCC as IC equals 0. This gives the point B, which means OB equals to VCC on the collector emitter voltage axis shown in the above figure. To obtain A, when collector emitter voltage VCE equals 0, the collector current is maximum and is equal to VCC by RC. This gives the maximum value of VCE. This is shown as VCE equals VCC minus ICRC. 0 equals to VCC minus ICRC. IC equals VCC by RC. This gives the point A, OA equals to VCC by RC on collector current axis shown in the above figure. Hence, we got both the saturation and cutoff point determined and learnt that the load line is a straight line. So, a DC load line can be drawn. Let's move to next question. Question 3C states that draw and explain input and output characteristic of transistor in common emitter configuration. This question carries 7 marks. The common emitter configuration is the most widely used transistor configuration. The common emitter amplifiers are used when large current gain is needed. The input signal is applied between the base and emitter terminals, while the output signal is taken between the collector and emitter terminals. The input characteristics describe the relationship between input current or base current and input voltage or base emitter voltage. The input current or base current is taken along y-axis and the input voltage is taken along x-axis. To determine the input characteristics, the output voltage VCE is kept constant at 0 volts and the input voltage VBE is increased from 0 volts to different voltage levels. The characteristic looks like forward bias diode curve. This is because the base emitter section of a transistor is like a diode and is forward biased. Input resistance. It is the ratio of change in base emitter voltage to the change in base current at constant VCE. Output characteristic of transistor. This is a plot of output current versus output voltage with constant input current. In other words, it is the curve between collector current IC and collector emitter voltage VCE at constant base current. The collector current IC varies with VCE between 0 and 1 volt only. After this, IC becomes almost constant and independent of VCE. This value of VCE up to which collector current IC changes with VCE is known as knee voltage. Note that the transistors are always operated in the region above knee voltage. Output resistance. It is the ratio of change in collector emitter voltage to the change in collector current at constant base current. The solution of other questions of this paper and many other papers are available on this channel and they are uploaded periodically. Thank you for watching Simply Study and don't forget to like, share and subscribe.